In this video, we're going to discuss the concept of the absolute value. So our definition of absolute value of a real number, a, the way we'll write this is put a and we put two vertical lines around it. So that's red. Absolute value a is just the distance from a to 0 on the real number line. So let's just look at a couple examples to help us see what that means. So we could talk about the absolute value of the number 3 or the absolute value of the number -3. So the absolute value of these numbers is just going to be the distance from 0 to these numbers. So if 0 is here, then 1, 2, 3, 3 would be here. So this distance here is the absolute value of 3. And just by counting 1, 2, 3, the absolute value of 3 is clearly 3. So absolute value of 3 is just this distance, which is 3. So that's pretty easy. The absolute value of 3 is 3. Now if we went the other way to -3, the absolute value of -3 would just be this distance from -3 to 0. So this distance right here. So that's the absolute value of -3. Well, again, the distance from here to here is just 1, 2, 3. Because distance is always positive, it's the positive distance, 3. So the absolute value of 3 is 3, and the absolute value of -3 is 3. So, as I just mentioned, since distance is always positive, that means that the absolute value of a is always going to be a positive number, or it could actually be, it's always going to be greater than or equal to 0 for all a values that are real numbers. Okay. So basically, absolute value is always a positive number. Some people will define it this way. They'll say it's whatever this number is without regard for sign. So if it's a negative number, it just becomes positive. If it's positive, it stays positive. And actually, we can kind of write that as a rule. And this is more of a formal definition. So in general, so here's a good rule for absolute value. We can write for the absolute value of a. So what we just said is the absolute value of a will be equal to a if a is positive. So if a is actually positive or 0. Okay. Right? Absolute value of 3 was 3 because it's just the positive number. But if a is less than 0, then the absolute value of a will change from a negative to a positive. So the way we would change a negative to a positive is to multiply it by a negative number, so it would be equal to -a. Okay, so that's our rule. This is a good rule here, or a good definition for the absolute value of a. This negative here sometimes throws people off. So let's just look at an example we'll look at the same example. Absolute value of 3. And we'll do this without using the number line. We'll just use this definition up here. Well, since we're looking at the absolute value of 3, and 3 is greater than or equal to 0, then we'll just use this definition here, and the absolute value of a, which is 3, will just be a again, which is 3. So since 3 is bigger than or equal to 0, right? Since we have this piece here, we're going to use just that definition. Now for the one that we said negative 3, well now negative 3 is less than 0, right? So we have this case here. So we have to use this rule. We have to take the negative of a, but a in this case is negative 3. So we have this negative, which is here, and this negative 3, which is this number here. Well, a negative times a negative is just a positive. So the absolute value of negative 3 is 3. So this negative here, a lot of people will say, okay, I thought absolute value has to be positive, why is there a negative in front of it? But you have to remember, because a is negative, you're going to end up with two negatives like this being multiplied, which will turn it into a positive number. So this negative is really to turn this into a positive. So it's just a good thing to remember when you're remembering that rule. Let me just for completeness, just to help us out, absolute value of 0, well, that's how far is 0 from 0 on the number line, and that's a distance of 0. It falls under this branch here, right? So absolute value of 0 is 0. Good thing to remember. Another one, absolute value of root 2 minus 1. Okay, so I'm going to want to simplify this. I don't want the absolute value signs. So what I need to know is this positive or is it negative? So is root 2 minus 1 bigger than or equal to 0? Which sort of, does it fall under here or does it fall under here? So what I'm going to do is I'm going to check what is root 2. You might know what root 2 is or have an idea, but if you don't, you can pull up a calculator. 2 square root, it's 1.4. It's about 1.4. It's a little bigger. So we have 1.4-ish minus 1. Well, 1.4-ish is bigger than 1. So the answer would be yes, this is bigger than 0. So by our definition up here, right, since we have it bigger than 0, then the absolute value of a will just be equal to a. Well, this is a, root 2 minus 1. So this is just equal to root 2 minus 1. I don't have to do anything. So that's that without the absolute value signs. How about one like this? So let's say we went root 2 minus 5. What's the absolute value of root 2 minus 5? Well, in this case, remember before, root 2 we said was about 1.4. So 1.4-ish minus 5 is going to be a negative number, is less than 0. So therefore, we're under this section here, right? Because our a value, our number in the square root, or in the absolute value, is less than 0. So we're going to have to put a negative sign in front of a. Remember, this is a. So we have to put a negative sign in front of this. So negative root 2 minus 5. And now we can just simplify by expanding the negative, or getting rid of the brackets. So negative root 2, and then the negative times negative 5 will become plus 5. And usually what we'll do is we'll just reverse these so that the negative sign's in the middle. So notice all we really did was just kind of reverse these. Root 2 minus 5 became 5 minus root 2. Okay, and any time where this is a two-term expression, where you're subtracting and it's negative, if you want to turn it into the absolute value, you could just do this. If you want to, just flip them instead of expanding this way. But if you want to expand this way, feel free to do so.